Alright, hello everybody. Welcome to Kazarma's video on displacement, velocity, and acceleration. This video is going to be a conceptual introduction to displacement, velocity, and acceleration. So I'm not going to be going over any formulas or anything like that. I'm going to be giving some more intuitive / visual examples to help you get a better idea of these concepts. But before I get into the definitions and examples, I did want to go over positive and negative in one dimension very briefly, because I'm not assuming anything about people's backgrounds in math beyond Algebra 1. So let me quickly explain this notation. So if you think about one dimension, it's like left and right. Like you can either go left or right, or you can stay right at the center. And so the center is usually marked at 0. And then the right is typically, so right here, is typically the positive direction. This is not always the case, but most of the time, the right direction is the positive direction. And then on the other hand, the left is the negative direction. So like -1 would be on this side and +1 would be on the others. Negative. There we go. So this is a general notation that I'm going to be using. I mean, some trick questions will switch the notation, but for the most part, I'm going to be following this notation. So if you're not familiar, that's a quick introduction. All right, from there, let's go into explaining displacement. So let me bring this. Let's first show the definition. So displacement is the minimum distance traveled between the starting and the ending position of an object, including direction. So this is a little bit, it's kind of a mouthful of words. It might be a little confusing, but I think displacement is best explained through examples. So let's go through my example number 1. So for example number 1, imagine you have a car. I'm going to be following a car theme through this lecture. Let's say if you have a car, and this car has traveled a windy path, so it's not a straight path, it's not direct, and it ends up at positive 25 meters. So in this example, the goal is to draw the path and the displacement of the car. So let's start by drawing the car. So if we have the car, say it's right over here, it's right here, and we know that it ends up at positive 25 meters. So because, like I mentioned at the beginning, positive is in the right direction, to the right in this context. We know it ends up to the right, but it follows a windy path. It's not direct. So let me draw an example. Let's see, let me make this a dotted line to show what the path could be. So the car starts where it's at, then maybe it goes to the right a little bit, then it decides to turn around and goes back, and then ends up going back to the left, and it keeps going until it reaches a delta of 25 meters. So let me change back to a non-dotted line. Here we go. So the car starts out at this position. Oops, accidentally erased it. So it starts off at this position right here, which we can say is 0 meters. And it says that it ends up at positive 25 meters. So that means that's the displacement. So that's the total that it's gone. So the displacement is not the line, that we've drawn, this windy path, because it's not the minimum distance traveled between the starting and the ending position of the object. So the displacement is this green line, and that green line has a length of 25 meters. 25 meters to the right. So this green line is the displacement. Whereas the path, or the total distance, is this gray dotted line. And that could be it could be 30 meters, It could be 40 meters. We don't really know. It's just the total distance that it went, but the displacement is just that direct line, the minimum distance, a straight line between the starting position and the final position. So let's continue with a second example. So let me take away the second box. So example 2. Just to help solidify that understanding. Example 2. So let's say you have a car again, and this car has traveled a windy path and has ended up this time at negative 25 meters instead of positive 25 meters. So again, let me draw a car. So let's say the car is right here. My funky car. It's like this. And the car, again, I'll use a dotted line to illustrate the path of the car. So the car is here, and we know, so it ends up at negative 25 meters. So we know it ends up to the left. It ends up at 25 meters to the left. So we have the dotted line. So maybe it goes to the left, and it decides to go backwards, and then it keeps going forward, and it keeps going, and it keeps going. So this, like I mentioned before, let me make this a line. This right here is the path, or total distance. And again, this could be, it could be 30 meters. It could end up being a total of like 30 meters. It could be 40 meters. We don't know. It's a long, windy path that the car went on. But the displacement is negative 25 meters. So we have, starts off here, and the car ends up at this other green point, and the displacement, this distance right here, this straight green line, that ends up being negative 25 meters, which is 25 meters to the left. So I hope that gives you a better understanding, a better intuitive and visual understanding of what displacement is versus the path or the total distance that a car went. Hoping that makes sense, let's move on to velocity. So let me move on to the next page. So let's start with the definition of velocity. So the velocity is the speed an object is traveling, including the direction. So you could have a car heading, it could head north, east, west, it could head right, it could head left, up, down, etc., and the speed. So let's go through an example to get a better understanding of this. So let's reveal example 1. So example 1, let's say we have a car, and the car is moving at 20 meters per second in the positive direction. So let's draw this example. So we have a car here. And the car is moving at positive 20 meters per second. So every second, the car is traveling 20 meters. And if you're not familiar with the unit of meters, meters is similar to feet. There's actually roughly 3 feet in 1 meter. So this velocity, so every second this car is moving at 20 meters every second to the right. So that's pretty straightforward. I think that's a pretty decent visual to help you get an understanding. Let's go to the second example. Let's cut this. So this example number 2. So let's say we have a car and it's moving, but instead of being at positive 20 meters per second, this time it's going at negative 20 meters per second. So we have a car, we'll have similar, my classic looking car. But since it's going in the negative direction, we know it's going to the left. So we know the car is going this way. We also know that it's going at 20 meters per second. So it's negative 20 meters per second in the left direction. So every second that is passing, the car is traveling 20 meters in the left direction. So I think that's velocity. You might have heard that word before in relation to cars or airplanes. But I hope this gives you a decent understanding if you are not as familiar with the term. Now finally, let's get into acceleration. Acceleration gets a little bit more complicated. So let's start with the definition though. So acceleration is the change in an object's velocity, including the direction. And a bit more of an intuitive way to think about acceleration is if something is speeding up or it's slowing down. So I think moving straight into my first example will give you a good idea of what acceleration is. So let's start with example 1. So you have a car, and the car is initially stopped, and we can say in this example it stopped at maybe a stop sign. And then it speeds up at positive 2 meters per second. So let's draw this example. So we start off, we have a stop sign. I'll draw a stop sign. It's going to be a funny looking stop sign. Stop. And the car stops at the stop sign. Let's draw my car. It stops, and it looks around. It sees that there's nobody else, and it decides to start speeding up and continuing on to where it's going. So if it's speeding up at 2 meters per second, and because it's at positive 2 meters per second, it's heading in the right direction. So, or to the right, 2 meters per second squared. And a visualization of this is when it's at the stop sign, or like right by the stop sign, it's at 0 meters per second. But then, after 1 second of time has passed, let's see, let me get the other, I usually use pink for time. After 1 second, so let's have this. After 1 second at a time, because drawings might not make sense right now, but let me draw this out to give a better visualization. After 1 second, it has sped up to 2 meters per second in the positive direction. And then after 4 seconds, or after 2 seconds, it's at 4 meters per second. And then after 3 seconds, it's at 6 meters per second. And what this means, so if it's accelerating at 2 meters per second squared, that means that the velocity is increasing by 2 meters per second every second that's happened. So this is, so this is after 1 second. This is after 1 second. Second. And so on. So it starts out at 0, but then it gets to 2 meters per second. It gets to 4 meters per second. It's getting to 6 meters per second, etc. So it's speeding up. It's going faster. So great, I think that's a pretty decent explanation of the first example. Let's go into the second example. So example 2, a car, and this time, this is not as good of a Samaritan, a car has driven past a stop sign, so the car blows through the stop sign at negative 10 meters per second, and it doesn't want to get caught, it wants to speed away, so it's speeding up at 2 meters per second squared. So draw this example. So here, let's say we have a car. We have a car here. And it's blown past a stop sign. So the stop sign's all the way back here. And so, let's see. So the car has blown past the stop sign at negative 10 meters per second. So at this initial point, it's at negative 10. So it's going in this direction. It's going to the left. It's at 10 meters per second. But it's speeding up at 2 meters per second squared. So because it's speeding up, or accelerating, it's implying that the acceleration is in the same direction as the velocity. So in this case, so the acceleration is in this direction. And so it's at negative 2 meters per second squared. If it's speeding up, same direction as the velocity. And similar to my previous example, let me make some dots. Like this is after a second, this is after a second, etc. And let me draw this in pink. So here we go. So this is 1 second, and this is 1 second. second. And so it starts out at negative 10 meters per second, but because it's speeding up in the same direction, it's speeding up by 2 meters per second. So after 1 second, it's now at negative 12 meters per second. And then after 2 seconds, it's at negative 14 meters per second. So it's speeding up. So let's draw these arrows in this direction. Great. So I hope that gives you a good intuitive understanding. Let me move on to example 3. So let's, example 3. So a car is initially traveling at positive 10 meters per second. So that means it's going in the right direction. But then it sees a stop sign ahead of it. So it starts slowing down, which is also called decelerating, at 2 meters per second. So let's draw this example. So we have a car. So it's initially, let's draw the car here. And the car is moving initially at 10 meters per second. So it's here. It's moving initially positive 10 meters per second. But then it sees a stop sign. So let's draw that stop sign again. Stop. There we go. And it realizes, okay, they want to be a good Samaritan, so they want to stop before they get to the stop sign. So they start decelerating. And if it's slowing down, this means the acceleration is going in the opposite direction of the velocity. So the acceleration is actually going this way. So it's negative 2 meters per second squared. So what's happening is after every second, it now goes to positive 8 meters per second. And then after another second, it's at positive 6 meters per second. So it's decreasing. Because every second it's subtracting 2 meters per second. So let me draw again. So this is after each of these. This is 1 second at each time instance. So this is 1 across 1 second, 1 second. So it's decelerating, it's getting slower. All right. Let me give one more example for this video, and then that, I think, wraps it up. So the last example is example 4, so pretty similar to example 3. So a car is initially traveling at negative 10 meters per second, but then it sees a stop sign and starts slowing down, decelerating, at 2 meters per second. Let's draw this example. So this time the car is going in the opposite direction. It's going to the left. So let's draw this car here. So it's initially heading in this direction at negative 10 meters per second. But then it sees a stop sign. So it sees a stop sign ahead. So here's the stop sign could be over here. Draw again one of my funky little stop signs. Stop. So it also wants to be a good Samaritan, wants to slow down. So if it's decelerating, slowing down, again, remember that means the acceleration is going in the opposite direction of the velocity. So this means the acceleration is actually going in the positive direction. So positive 2 meters per second squared. And so this means every second as it's going further left, it's slowing down. So after 1 second, it's at negative 8 meters per second. After another second, it's at negative 6 meters per second. So it's slowing down. So let me draw these arrows for them. And then let me draw the time delta. So after each of these instances, 1 second. So this is 1 second and 1 second. So as it's going to the left, it's slowing down every second. It decreases by 2 meters per second because it's decelerating in the opposite, or it's accelerating in the opposite direction, which means it's decelerating. So I know this can get a little confusing, but if these concepts are still a little jumbled in your head, like what's the difference between decelerating, accelerating, slowing down, speeding up, and its relation to velocity and the direction of the velocity, don't worry, you can watch this video again. I'm also going to be attaching a link at the end of this video so that you can download this PDF of my notes if you want to just look at a PDF copy instead of having to rewatch the video. But that's it for this video. I hope you guys enjoyed this, and I hope to see you next time.